this video, we are going to discuss evaluating functions. The objectives for this video is that the learners must be able to evaluate functions and to solve problems involving functions. What do we mean by evaluating a function? Evaluating a function means replacing the variables like x, y, or z or other variables in the function with the value from the function's domain and computing for the result. So now, we are going to solve the following examples for us to know how it is really to evaluate functions. So given the following functions like f of x, q of x, g of x, r of x, f of x, and t of x. Now, we are asked to do the following. Number 1, evaluate the given functions at x which is equal to 1.5. Number 2, find g of -4 and r of 1. Number 3, evaluate the following functions, f of 3x minus 1 and q of 2x plus 3. Now, these would be the solutions of the examples. Number 1, evaluate the given functions at x is equal to 1.5. For the first function, which is equal to f of x is equal to 2x plus 1, all we have to do is to simply replace the value of x with 1.5. Thus, the function became f of 1.5, which is equal to 2 times 1.5 plus 1. So, we just simply replace x with 1.5 both sides of the equation. Okay, now simplifying the results, 2 times 1.5 is equal to 3 plus 1. Resulting value would be 4. Thus, f of x is equal to 4. Now, for the second function, q of x is equal to x squared minus 2x plus 2. Again, replace x both sides of the equation with x which is equal to 1.5. The function became q of 1.5, which is equal to 1.5 squared minus 2 times 1.5 plus 2 is equal to 1.5 squared is equal to 2.25, and negative 2 times 1.5 is equal to negative 3, bring down plus 2. Hence, 2.25 minus 3 plus 2 is equal to 1.25. Thus, q of x, where x is equal to 1.5, is equal to 1.25. And now, for the next function, which is g of x is equal to the square root of x plus 1. Okay, evaluating such function means that x both sides of the equation has to be replaced with 1.5. Thus, the function became g of 1.5 is equal to the square root of 1.5 plus 1. Thus, g of x, which is equal to g of 1.5, is equal to the square root of 2.5. And now, for evaluating the next function, which is r of x is equal to 2x plus 1 all over x minus 1, we will do the same thing. That is, x both sides of the equation has to be replaced with 1.5. So, the function became r of 1.5 is equal to 2 times 1.5 plus 1 all over 1.5 minus 1. Okay, now simplifying both fractional part, we would be able to get 3 plus 1 all over 0.5. The numerator now is equal to 4 all over 0.5 is simply 1/2. So the fraction now becomes a complex fraction. Simplifying a complex fraction would mean the numerator has to be copied, change the division operation into multiplication, and reciprocate the denominator. Thus, this becomes 4 times 2 over 1. And so, the final answer would be 8. Therefore, r of x, in which x is equal to 1.5, is equal to 8. And now we are heading to second to the last function, which is f of x is equal to the floor function of x plus 1. floor function of x is actually the greatest integer that is less than or equal to x. Till the x has to be replaced with 1.5, both sides of the equation. And now, the function became f of 1.5 is equal to the floor function of 1.5 plus 1. Now, let's have a simple recall as to how we could be able to get the floor function of a certain number as well as the ceiling function of a specific number. What is the value of the floor function of 1.5 and the ceiling function of 1.5? The value of the floor function of 1.5 is equal to 1 and the ceiling function of 1.5 is equal to 2. And now the function becomes 1 plus 1 since the floor function of 1.5 is equal to 1. Hence, f of x, in which x is equal to 1.5, is equal to 2. And now, for the last function, which is t of x is equal to the ceiling function of x plus 1, all we have to do is to simply substitute x both sides of the equation with x, which is equal to 1.5. So, the function becomes t of 1.5 is equal to the ceiling function of 1.5 plus 1. Remember that the ceiling function of 1.5 is equal to 2. Thus, the function now becomes 2 plus 1, which is equal to 3. Hence, t of x, where x is equal to 1.5, is equal to 3. Now, for number 2 example, find g of negative 4 and r of 1. Our answers for this are as follows. G of x is equal to the square root of x plus 1. Replacing x both sides with negative 4, the function g of x becomes g of negative 4 is equal to the square root of negative 4 plus 1, which is equal to the square root of negative 3. But the square root of negative 3 is said to be an imaginary number. Therefore, this is not possible because negative 4 is not in the domain of g of x. Now for the function r, which is r of x is equal to 2x plus 1 all over x minus 1, x has to be replaced with 1 both sides of the equation. So, the function now becomes r of 1 is equal to 2 times 1 plus 1 all over 1 minus 1. Simplifying both numerator and denominator, we would be able to get 3 of 1 is equal to 3 all over 0. Remember that all fractions whose denominator is equal to 0 is called to be undefined. Hence, this is not possible because 1 is not in the domain of r of x. And now, for the third example, we are asked to evaluate the following functions: f of 3x minus 1 and q of 2x plus 3. We have to recall that f of x is equal to 2x plus 1 and q of x is equal to x squared minus 2x plus 2. So, starting with the first function, which is f of x is equal to 2x plus 1, replacing x with 3x minus 1 both sides of the equation, we have f of 3x minus 1 is equal to 2 times 3x minus 1 plus 1. Simplifying the results, we would be able to come up with 6x minus 2 plus 1. What we did is we simply distribute 2 to each term of the quantity 3x minus 1. So 2 times 3x is equal to 6x and 2 times negative 1 is equal to negative 2, then bring down plus 1. Combining minus 2 plus 1 would give us 6x minus 1. Hence, f of 3x minus 1 is equal to 6x minus 1. Now for the second function, q of x, which is equal to x squared minus 2x plus 2, this time our x, both sides of the equation, has to be replaced with 2x plus 3. Thus, the equation became q of 2x plus 3 is equal to the quantity of 2x plus 3 squared minus 2 times the quantity of 2x plus 3 plus 2. Now it gives us 4x squared plus 12x plus 9 minus 4x minus 6 plus 2. We need to combine similar terms like 12x and negative 4x. Also, we have 9, negative 6, and positive 2. Hence, q of 2x plus 3 is equal to 4x squared plus 8x plus 5. Thank you so much for watching. I hope you learned a lot from my video lesson.